Okay, everybody, welcome. I finally got a document cam, so I'm trying to figure this out. But I did chapter 5 and I made a whole video, but apparently sound didn't come out. So I worked it all out. So I'm going to show you the problems and show you the answers, and hopefully next time I can get the sound working as well. All right, so just bear with me here. All right. I hope everybody can see that clearly there. This is the introduction to chapter 5. This is 5.1. And again, I'll probably print this out or maybe take a picture and upload it so you can have the notes as well. But hopefully you can follow me in the video here. 5.1 is simple interest. Simple interest is calculated as what's called the principal times the rate times the time. The principal is also known as the present value. It's how much money at the beginning, how much you invest or how much you borrow. The T is how many years you invested or borrow. The R is how much percentage they charge you, and I is a simple interest. Future value is how much you have at the end. It's how much essentially you put into it, or sorry, you get out of it at the end. The future value is defined as the principal, which is the money you started with, plus essentially the interest that you have to pay. So it's a total. Because interest is principal times rate times time, you could factor out a p from this, and so you get p times 1 plus rt. So these are two different formulas. So the future value is the present value times this parentheses. If you divide both sides by this parentheses, you can figure out the principal value if you're given this other values. So I've written here a number of different formulas. And what I did here, I already did a video, but no sound came out, so I'm repeating myself here. So I'm going to walk you through this kind of simply here. Find the interest rate paid back at $8,000 borrowed for 6 months. Okay? So it says find the future value. So essentially what I did was notice here, see if I can get this to kind of fit up here. Notice that the money you borrow is $8,000 as your principal. Your time is 6 months. Now this is out of 12 months. This is per year. So out of 1 year, there's 12 months. So 6 months is 6 out of 12, or half a year. The interest rate was recorded as 3.4%. But when you have a percent, you want to put it as a decimal. So you must move the decimal 2 places to the left, and so you get 0.034. Then you have the principal, which is 8,000. You have the rate, which is 0.034, and you have the time, which is 0.5. So when you put that into the formula and you calculate it, you get approximately $136. So that's the interest paid. Find the future value. The future value is the principal, or the present value, which is what you started with, plus the interest, which is 136. So you add them up and you get 8136. Again, just so we're clear on this, 8,000 times 0.034 times 0.5, half a year. So, excuse me here. I don't know if you can see that or not. I'll move it close in a second. 8,000 times 0.034 times 0.5. So I don't know if you can kind of see that clear or not. Just kind of punch it in and you get your values. Then you add the 2 and you get your answer here. So in number 2, it says find the interest paid back on 5,000. So that's your principal or your present value. The number of years is t. This time it's 8 years, so t is just flat out 8. And the interest rate is 6.3%. So 5,000, 8 years, not out of 12 months because it's number of years now. You move the decimal to interest rate 2 places to the left, you get 0.063. You get these 3 values, you get the same formula, P times R times T, you plug it in, and you get 2520. So just really fast here, I don't know if we can, sorry. I don't have much space to deal with here. 5,000 times 0.063 times 8. Again, I don't know if that comes out well or not, but that's your 2520. You take a 2520, which is your interest now, and you add it on to how much you borrowed, it adds up to 7520. And that essentially will be problem number 2. Problem number 3, find the present value on $52,500 owed after 4 years at an interest rate of 8.1%. In this case, it says find the present value. It's giving you the future value, it's giving you the time, and it's giving you the R. So it's giving you these values, the future value, the rate, and the time. So we're going to use this formula. So future value That's what's given. The time is 4 years. The interest, again, move the decimal 2 places to the left, 0.081. This is your formula. Future value divided by 1 plus r times t. So taking these three values, put into this formula, you have this setup and then this answer. So here, like I said, I did it before. Till this comes out here. 52,500 divided by parentheses 1 plus 0.081 times 4, close parentheses, and that's where I got my number, $39,650. And notice I'm going to go 57 because it's the money, so I'm going to go 2 decimal points. After the 6, that number 7 is 5 or higher, so this is going to round up to 57. So that's why I got this number. Like I said, I did all this ahead of time or in the video, but I didn't have any sound, so I'm going to walk you through this kind of quicker here. So that's how much. So what it's saying is, if you wanted to end up with $52,500 over 4 years at this interest rate, then you'd have to deposit this amount or borrow this amount to get to that point later. So it tells you the end and it wants to know the beginning. And then number 4 is essentially the same thing. Find the present value on another future value, 20,000, after 9 months and 10% interest. The only thing different here is 9 months. So it's not quite a year. So it's 9 out of 12 months here, as one of the earlier examples. So the T is 9 months, 9 out of 12 years, 9 months out of 12 months, or 3 out of 4, or 0.75. I'm going to use a decimal. The future value is 20,000. The interest rate is 0.10 because 2 decimal places to the left. I take these numbers, put them into the same formula up here, which again is this formula, working the principal backwards, or working for the present. You know the future, you want to figure out the present. So again, 20,000 divided by parentheses 1 plus 0.10, and that's not an x, or that's times. My fault. It looks weird. 0.75, and as you close it, you should get, what is that? $18,604.65, which is what I put here. Okay, and then you have the last two here. An account grew from 50,000 to 60,000 in 3 years. What is the interest rate? So this is more you want it to go back as the interest rate. Now, essentially, the interest rate is in two formulas: this one or this one. Now, if you have the future value, which you do, again, present value is 50,000, future value is 60,000. T is 3 years. So you have the future, you have the present, and you have the time. So you can figure out R from this equation. Or you notice the first equation has present times rate times time. You have essentially, let's see, you have the time and you have the present value. So if you can figure out how much interest, you can solve a simpler equation for R. So I'm going to do that. So you notice that if it grows from 50 to 60,000, the difference is the interest. So to figure out the interest, it's 60,000 minus 50,000. That's your interest rate. Your time was given as 3 years. Your principal or your present value is 50,000. So if you have the formula, and I'm sorry here, I already worked it out. The interest equals P times R times T. And what I did here, notice that I divided both sides by P and T to get R essentially by itself. So R would be interest divided by principal times time. Well, you have interest, you have principal, and time. So you have these three values, plug it in and solve for R, which is what I did over here. And so again, I'm sorry, I know my times don't look a little bit different. So I'll put a dot if it makes it easier. I don't know. So now, if I may here, 10,000 divided by parentheses 50,000 times 3. And this gets a horrible number. So what I went ahead and did, oh, sorry here. I didn't go all the way up here. So I went ahead and I got a horrible number, but I rounded off to 4 places because once I get the decimal, I want to go back to percent. Earlier, I went from a percent to decimal by going to the left. Now I'm going to come back to the right to get a percentage from a decimal. So this gives me 6.67%. That's my interest rate. And then finally here, Jane invested $10,000, interest rate of 2.9%. She went back and her investment grows to $15,000. Approximately how long did she invest? Now, what makes number 6 different from number 5 is that I give you the interest rate and I'm looking for the time. In the previous, I gave you the time, I'm looking for the interest rate. So I'm going to do number 6 like I did number 5. In essence, the end minus the beginning, future minus present, that's your interest rate, your interest, the total simple interest. Then your interest rate percentage, move 2 decimals to the left, 2.9% becomes 0.029. Your present value is 10,000, your interest rate is 5,000, your present value is 10,000, your simple interest is 5,000, your interest rate is 0.029. So if you take I equals P times R times T and divide both sides this time by P times R to cancel the P and the R. So you get T by itself and you get I over PR. So you have I and PR, their values, and you plug it here. And again, I'm sorry for the X, I just happened to do it. And so when you do that, let's see if I can get that in there. 5,000. I can't really see the screen there, but it's okay. Divided by parentheses, 10,000 times 0.029, close, and then hit equals. And that's, oh, geez. 10,000 divided by 0.029. Oh, I'm sorry. It's a good thing I did this thing over. T is approximately, again, 5,000 divided by parentheses 10,000 times 0.029. It's actually 17.2 years. So at this interest rate at 2%, it should take about 17 years to jump $5,000, which it actually makes sense. 1 year didn't make sense. I did this kind of fast here, but hopefully this concludes chapter 5.1. I'm gonna upload it soon, and hopefully you'll have it for your records. Sorry for the mess, but I'll do better on the next one.